So here's the way we're going to do it. I'm going to ask you all to hold up a hand right now. Everyone hold up a hand, okay? And in a second, you're going to hold up a number of fingers, either 1 or 2. Here's the way we're going to do it. If you think that pace, how fast I'm running, is the independent variable, then in a second, I'm going to ask you to hold up 1 finger. And if you think kilometers is the independent variable, then I'm going to get you to hold up 2. Okay? 1 finger, let me write it down. 1 finger for pace as independent and 2 for kilometers. Ready? 3, 2, 1, make your call. All right, just look around the room for me. Look around, look around, look around. So let me see if I remember this. Most of you are suggesting that kilometers is the independent variable. Is that right? Almost all of you. I've got 1 dissenting opinion down here. Anyone else game? Sabrina's like, I'm not sure. Okay, hands down, hands down. All right, so hands down, the vast majority of you think that kilometers are the independent variable. So give me some justification. Anyone? Josh?
The longer you're going to end up running, you end up running slower instead of anything.
Okay, so here's a way that I said, the dependent variable, the dependent variable changes in response to the independent variable. So Josh, what I'm hearing is that kilometers I can change to be whatever I like, but then my pace slows down. It's the one that depends on kilometers. Is that a fair, were most of you thinking along those lines? Yeah? Which is a fair call, right? In fact, in reality, that is what I do because I don't have very good control of my pace. I run as fast as I can and then I just slow down, right? However, if I were a serious runner, I'm just amateur. If I were a serious runner, I'm going to suggest that most of you would be wrong. Actually, pace would be the independent variable and kilometers would be dependent. Now, Michael, I'm not going to necessarily put you on the spot because you're the only person, but you said, do you want to suggest a reason why it would be the other way around?
Because it's something that you actually directly control rather than something that's remotely controlled.
Aha.
I'll speak from an scientific, from an experimental perspective.
Okay, so did you catch that, right? Let me say it again, because it's tricky, it's a big room. Pace is something I actually do have very, very direct control over from a moment-to-moment basis. And so do you. Am I going to run fast as I can? Am I going to sprint? Or am I going to take it easy so that I can go a longer distance? Okay. Now, in fact, there have been, I excluded this data from the set, but there have been times where I've literally said, okay, I'm just going to run as fast as I can. And at a certain point, I just can't run anymore, right? And instead of slowing down, I just stop and I call it. I'm like, okay, watch, you're done, right? There are a couple of ones down here in the lower areas where if I sprint as fast as I can probably go about 2 kilometers and then I'm done for the day, okay? There's no more running that happens after that. I'm walking home, okay? In that case, do you get this? The independent variable will be pace. In fact, if I were a real trainer, the real reason why I would do that is because you've got to do what they call high intensity, low intensity, and they train you in very different ways, right? One gets speed, one gets duration, okay? My key point here is you've got to think about these things and the answer is not always obvious, okay? So that's the first thing. The second thing is these two concepts are clearly connected, as we were just pointing out. So there's a word that we use, a technical word that we use when two variables like these connect in a way that you can see in the data. Start to see. Anyone want to tell me what it is?
Correlation.
It's correlation. Can you please jot that down underneath where you wrote independent and dependent variables? So we see this relationship between, in my case, kilometers and pace, right? But the correlation is actually, it's pretty decent, right? The longer I run, the slower I go, okay? Now, it's important to recognize that sometimes you have what we call a really strong correlation. The connection between these two things is very obvious. Now, other times it's not so obvious, and I kind of feel like my running data sort of fits into maybe this second category here if I had more runs on the board, right? We would say after strong, you might have a moderate correlation. Down here, it's it's actually quite vague, but vague is not the technical word they use. The technical word they use, does anyone know, is it's not strong, it's weak. And lastly, we need to remember, sometimes there is just no connection whatsoever. Sometimes there is no correlation. So you would say none. You can look for a pattern in the data, but sometimes it is not there. And you search in vain for some kind of connection. Okay? Now, you can do a very rough version of these. Obviously, you don't need to make it super neat. You don't have to draw nice, neat circles and that kind of thing. But if you were to draw a line of best fit, we've looked at these already, right? A line of best fit across all of these, they would look something like, let's go ahead and just put some on, right? something like these, yeah? They would still, even though there's a weakened connection here, you would still say this line is going sort of in that direction, okay? What is the gradient? What can you tell me about the gradient of each of these lines of best fit? They're all roughly the same, right? And importantly, they're all increasing. So these would be what we call a positive correlation, right? There is no reason why a data set should have to look like this. In fact, I can take exactly the same data that we just looked at with my running. Here it is right here. This is exactly the same data, but suddenly it looks really different, okay? Now, I'm going to spoil it a little bit for you, but it's not that hard to see. My horizontal scale is the same, 5, 10, 15, 20, etc. It's still kilometers, okay? But have a look over here now on the left. Before I reveal it, what does this now look like in terms of a vertical scale? Because it's not pace anymore. Still the same data set. What do you reckon, Sebastian?
It should be minutes.
Minutes of what exactly? Like duration? Like how long I've been running?
Yeah.
So let's have a think about this, right? Does that fit the data? Would I have fewer minutes as I run further? Okay, so we know it's not a bad hypothesis because this has to do with minutes. I'll give you another clue. It is to do with time, but it's not that. What do you reckon, Ian?
It's like your average speed.
This is speed. And it is actually, in fact, average speed because it's over an entire journey, right? So now you can see the fact that I'm running slower. Perhaps you might find this is actually a more sensible graph, right? Because slower means it's going down, right? I'm down here kind of around 12 kilometers per hour-ish, right? Think about that. Exactly 12 kilometers per hour would be precisely 5 minutes per kilometer, which you saw I was close to up on that graph before, but a little bit faster, right? So this is no longer, like if we drew on a line of best fit here, it might look something like that. Do you agree? The gradient is not positive anymore, it's negative. So this is no longer a positive correlation, it's a negative correlation. Same data set, just visualized differently. Make sense?